Hello. Today we are going to talk about how to mill PCBs with MDX-40 milling machine, so the Roland MDX-40, in a specific context, in the Fab Academy context, using mods and pre-made SVGs. So today I made some SVGs that are for Hello World project for ATtiny 1614 that is based on design from the Fab Academy curriculum, and I'm going to show you how to create two paths for the MDX-40 machine using mods. So let's get started. So in order to start the process, we will need a few SVGs. So these two SVGs I exported from KiCad. So the one is for the traces, and the other one is for the edge cuts. So for the traces, you see there's the project name, which is Hello ATtiny 1614 Blink. So the board is so it's designed so that it contains an LED that can be blinked if you upload the correct code to it. And then FCU means front copper, so it contains the front copper traces that we are going to mill with the milling machine. Then the other one again contains the project name in the front of it and its edge cuts, which means that it contains lines that are supposed to represent the outline of the board, and which also has to be cut. So here on the desktop I have the mods icon. So this computer here is the computer that is connected to the MDX-40 here, the Auto Fab Lab. You can double click this icon, or you can open the browser and you can go to this address, mods.cba.mit.edu, and you can start from here. And what we need to do, we need to load a server program. So I'm going to right click and I'm going to go to programs, open server program, and down to SRM20. So SRM20, because there is no entry for MDX-40, and basically it creates the same code, the same G code, or RML. So RML probably is like Roland machine code, Roland machine language code. And we are going to create a PCB, so this Roland machine language code from an SVG. So we select this SVG option here, and it loads us this network of nodes. And the first thing that we have to do, we need to select an SVG file, and thus we go to the desktop and we go to the project folder, which in this case is Hello T1614, and we go to the SVGs folder. So in your case it's going to be different for sure. And I click on the front copper file, click open. One thing that we need to do is we need to invert the design, and I'm also going to increase the dpi to 1000 dpi, like so. The other thing that so we need to invert it one more time. So make sure that it's inverted, because the white areas, they are going to be left on the board, and the black area is what we want to be removed. So imagine that this board is all covered with copper, so the white areas we want to leave and the black areas we want to remove. And here we need to select the mill traces option, and it's going to give us presets, and in this case we want to use milling bit that is 0.4 millimeters in diameter. So these are values that are calculated taking into account fractional tool diameter values, but in our case we know that our tool is 0.4 millimeters, so in the diameter, so we're going to enter a precise value over here. And for the depth of cut, 0.1 millimeters is fine, but I'm going to go with a little bit more, so like 0.125. So offset, so this is how many times do you want the tool to go around each of these traces here. So in our case 4 is a nice number, so it means that in the case of 0.4 millimeter, it's going to leave a almost 1 millimeter gap or space between the traces and the rest of the copper. And so yeah, we could also clarify the step over, but 0.5 millimeters is fine. So another thing that we need to do, we need to replace the WebSockets device with file entry. So we delete this. So we go to modules, and then we open a server module, and we go to file, save. Then click on the output file and here on the input file, so they connect. And here then for the Roland SRM20 milling machine module, so which could be also, so which basically we are using as MDX-40 milling machine, we are going to change the speed to something that is good for our tools. So we are not using solid carbide tools, but we are using high-speed steel. And from the experience here at the lab, it seems that 1.5 to 2 millimeters per second is a good value. So I'm going to go with 1.5 millimeters per second. And the origin, it's easier for me at least to understand where the tool is going to go and how it's going to mill if the origin is 0, 0, 0. So this is going to be relative to the actual machine origin that we are going to set later. Then the jog height, it's so how the tool is going to move from place to place without cutting traces in between. So it's gonna be lifted 2 millimeters above the surface of the copper and then move to another location. And then home location, so I'm also going to set 0, 0. So this is where the machine is going to start milling. So the position from which the machine is going to start to mill, and also where the machine is going to go at the end after the milling job is finished. And in this case, I want it to start from 5 millimeters above the ground, above the surface of the copper. So I'm going to enter 5 millimeters for the z-axis. And at this point, I'm ready to actually calculate the paths. So I'm going to click on calculate. And here we see that we have a nice tool path that nicely eats the copper around all these traces. So make sure that there's something that goes in between your pads. So there are like 2 lines or 2 tool paths going in between the traces. So they are going to be separated nicely. Yeah, overall it looks good. So we can close this tab. And also at the same time, so the pipeline of these modules, so it went through until the save file part, and it saved file with the name Svg image RML, which is not the best name. And we could go to the folder where it's saved now, and we could do a little bit of renaming. So I'm gonna enter hello T16414 blink traces RML, and I'm going to open a new window and create a new folder here. There is an RML folder already, so I'm just gonna delete these previous RML files. And yeah, so this is for the traces, but we need one more file for the outlines. So I'm gonna repeat the process. I'm gonna refresh the page and start from 0 again. So yeah, just for the reference, so you can better understand what has to be changed and you do not miss anything. So you go to so you start with right clicking, then programs, then open server program, and you go to SRM20 and choose the PCB SVG entry here. So it's going to open this network. So you start with selecting an SVG file, then edge cuts, this time edge cuts, because we want to cut the edges. Open it up. I'm going to set the dpi to 1000 here, invert it, yeah, so that the background is black mostly. Then I'm going to select mill outline, And this time I know that my tool is going to be 0.8 millimeters. So I'm going to select 0.8, and the cut depth is going to be 0.6, and the total depth is going to be 1.8 millimeters. So the thickness of the board is 1.6 millimeters. We want to go a fraction of a millimeter, so 0.2 of a millimeter above the edge, so below the edge. So we make sure that the cutter actually cuts through the board. And again, we need to make sure that we replace this WebSocket device with a file module. So we right click and select modules and open server module and go to file, save, pull it here, click on this file output and on this file input. Now they are connected. So for cutting we can go with 2 millimeters per second, and for the origin again we enter all zeros. Jog height can be left as 2. Then for home position 0, 0 and 5 millimeters is fine. And now we are ready to click calculate. So calculating. And what we got here is nothing for some reason. So let's go back and check what could be wrong. Fill background. What if we invert? What if we set this to 500? Invert and then calculate once more. Yeah, now we got something. Let's view. Yeah. So now I get a nice outline, so it should be precise enough and it should leave the board in the size as we want it to be. And it also saves us, it's on the disk, so this should be the file. So hello T1614 blink cuts, or yeah, edge cuts. Oh, just cuts. Like so. And we open the other part where we store the RML files, not SVGs. Let's go from downloads, let's pull this RML file to the RML file folder. Yeah, so now that's that. Next thing is we need to open vPanel to control the machine. Like so. As for the machine, we need to change the tool, and so with this controller panel, so Roland vPanel software, we can move the tool around by using these arrow keys over here. So, and here there are 5 different settings that you can use in order to move it around. So if you choose one step, then you're going to move the tool just by 1 step, which equals 1/100 of a millimeter. Then 10 steps is 1/10 of a millimeter, and 100 steps is 1 millimeter. And if you select low speed and you press and hold the mouse button, then it moves it slowly, and if you select the high speed setting, then moves it quickly. And let's quickly move it to the position so it hovers the actual material that is set up here. So the material is just a single-sided copper clad with a double-sided tape on the other side. So yeah, there are many ways how to attach that to the sacrificial layer, but this yeah, the double-sided tape, it should be easy to grasp. So, and we can go also a bit down like this, and then the next thing that you need is these 2 tools in order to open the collet so that we can insert the tool. And so for milling the traces, we'll need also 0.4 millimeter tool for PCB milling. So these you can find easily just next to the milling machine. It should be easy to find. If you cannot find it, then just ask around. And here, so we're gonna remove the previous tool, like so. Do it carefully. Make sure that you put it back in the enclosure so it doesn't break accidentally. And let's install the 0.4mm tool now. This one. Now the first thing that we will need to do is to actually set the Z, the Z calibration, the Z home. So let's move it a little bit more above the copper clad, so like this. Let's move it closer like this. And then here on the side here on the side of the machine, you can see that there's a sensor. So we need to use this sensor and put it under the tool, like so. And then at this point we have to close the lid. Also need to check the connections that they are okay, so that because the measurement is going to happen in a way that the tool is going to drop slowly, and the Z origin is going to be set at the point when the tool is going to touch this capacitive sensor. So let's move back a little bit, close the lid, we can move back in like so. So you can see what's going on there with the sensor. Now I'm gonna and here in order to set the Z origin, you have to select the set Z origin using sensor option and click detect. And vPanel is going to ask you whether you're sure whether you have done everything that is necessary in order for this operation to be safe. So we have done everything, so we can hit continue. Yeah, now it will touch the surface of the sensor. And what you should do is wait till the tool moves up completely, and that in the controller software you see the detection operation has finished, and you hit OK. Don't rush to open the lid. Yeah, because we have to do so because we want to remove the sensor from its current position. Let's move back a little bit. Open this and put it back in the pocket here. And now what we have to do is to calibrate to set the X and Y origin. I'm going to move the tool down. Try to do it slowly, preferably with the low speed mode. And then with the high speed mode you can move XY faster, but once you want to be more precise, then you need to switch over to the low speed mode. So in order to better see where we are, another important thing that you need to keep in mind is that you should be in the user coordinate system. Make sure that that you check that before you set the z-axis as well. Yeah, this is very important. And if you've done the z calibration while being in the machine coordinate system, then make sure that you set it to user coordinate system and do the z calibration again. And here I think now the position of the XY is good enough, so we can actually set the XY origin. So you see that there are different options, and since we want to set the XY at the same time, then we select to set both at the same time and hit apply. You see this XY is getting to 0, and Z is almost 5 millimeters, and if you check closely, so you can see that it's approximately 5 millimeters above the upper. We can again move back a little bit. Have to close the lid. Can move it. Now I have to load the file and start milling. So here, before you start milling, check the setup. And as we are using RML code, so make sure that you have selected this RML1 option here. And this is the place where you can also control the thickness of the Z sensor. So it's 15 millimeters, that's fine. If you change this value, then you need to set the Z origin once more. So let's hit OK, so these values are OK. I am going also to preset the spindle speed, because that's the code is for SRM20 machine, and there is no entry which specifically defines the revolutions per minute of the machine. So I'm going to assume that 7,500 is an OK rotation speed. So this machine can go up to 14,000 revolutions per minute, but I'm just going to go with 7,500 in this case. Also, yeah, so user coordinate system, that's all fine. Let's hit cut. I will delete all the previous files that have been cut here, and then I'll click on add, go to desktop, look for the project folder, and click on RML, and choose the traces file, and hit open, and then hit output. And if you want control, if you want to check before it cuts whether everything is fine, you could also slow down the feed rate, but in this case I think we did all the calculations right. And now we wait. So okay, we can see that the milling has finished, and what we need to do now, we want to take a look how clean the cut is. So we zoom out, we open this up, and we take the small vacuum cleaner, and one more thing. So before we zoom out, and here on the panel you can see that there's the view button, so you press that. And what is going to happen, the machine is going to move the build plate forward, so you can see the actual result, so you can access it with your hands. So you open this up, zoom in here, and then you away to So as we can see, there are some parts that are not completely cut. So that is probably because the surface is not completely even. We want to change the tool from 0.4 millimeters to 0.8 millimeters. So first we are going to remove the existing tool. Like so. And let's put it back in its enclosure. 8 tool. Here we go. And after the tool change, we can leave the X and Y origin the same, but we will need to recalibrate the Z. So in order to do that, I'm again going to take this Z sensor here, and I'm going to put it on the board like this. Move the tool so it is above the sensor. Select the Set Z origin using sensor option. Make sure that user coordinate system is set and hit detect. It's gonna again ask whether I have done all these things, and then I hit continue. Now it's going to move down the tool. Hit the sensor and register the Z origin. And again, remember to wait till it finishes the operation completely, so this menu shows up. You can click OK, and only then move out and remove the sensor like so. And now we are ready to launch the outline milling job. Again, check whether RML1 is selected. Then cut, delete the previous jobs, add, link cuts, open, output. Okay, and we are done. So now, let's wait till the spindle finishes spinning completely, and it takes approximately 5 seconds for it to slow down completely. Then we zoom out and we take a look at this panel over here, and we press the view button. I'm just going to lift the tool, and it's going to move the board forward so we can access it. And once it's done that, then we can open this up, zoom in, and hello, there's our board. And then we take the vacuum cleaner. And then we can use a knife like this in order to remove the board. So just remove the piece that you want to remove. So in case somebody wants to mill a smaller piece, just right after you, so you can save the material. You see, so on the other side there's double-sided tape. So, and this one you can remove quite easily by just using your fingernails or something sharp. Like so. Yeah. And oh god. And this is our board. So we see that there's a bit of an error in the corner, but this can be fixed. So basically this would be fixed automatically if we would make sure before that the sacrificial layer is flat, so which I think is the next thing that I'm gonna do. Always remember after milling also to remove the tool so that the machine is nicely set up for whoever wants to use it next. So the tool, put it back in the box. Put it in the rack next to the machine over here, and that's that. Also the key. So yeah, that was PCB milling with MDX-40. So